Rajeshwar, I think we shall start.
Yes, sir.
Yeah, please.
Good evening to all. First of all, I would like to extend a very warm welcome to all of you to the fifth session of two-week hybrid mode Atal Faculty Development Program on Advanced Computational Intelligence Technique for Engineering and Science Applications. This program is jointly organized by Chemical and Computer Engineering Department, MIT Jaipur. Today's session is divided into three sections. First and second section will be for guest presentation, and third section will be for interaction with participants. In between three sections, there will be a break for 10 minutes. Now let me introduce today's guest of honor, Dr. Anshuman Kalla. Dr. Anshuman Kalla is working as a professor at Department of Computer Engineering in Yuka Tarasdia University, Bardoli, Gujarat. He graduated as an engineer from Government Engineering College, Bikaner in 2004. He did Master of Science in Telecommunications and Wireless Networking from Paris, France in 2008, and another master from University of Nice Sophia Antopolis, France in 2011. Dr. Kalla was recipient of master scholarship for pursuing both the master program. He obtained a PhD degree in 2017. He has more than a decade of teaching and research experience. Dr. Kalla is a senior IEEE member. He has worked as a postdoctoral visiting researcher at a Center for Wireless Communications at University of Oulu, Finland. He has delivered invited sessions and talks during various short-term courses, faculty development programs, workshops, and conferences. In particular, he has delivered tutorials at IEEE and 2020 and IEEE 5G World Forum 2020 and 2021. His area of interest is blockchain, 5G, 6G, IoT, information-centric networking, software-defined networking, and next-generation networks. It was all about today's speaker introduction. Today we have such a great personality with us. Now I would like to request today's speaker, Dr. Anshuman Kalla, to start the session.
So we all welcome to Dr. Kalla. Thanks a lot.
Hello? Dr. Anshuman is not audible.
Oh, I'm so sorry. So where was I? I was not audible from the beginning.
Yes, yes.
Oh, I'm so sorry. So okay. I'm so sorry. Thank you for the interruption. So yeah. So thank you for today's introduction, and let me just quickly give a recap of what I spoke just now. So the today's session is on, as you can see on your screen, is on blockchain and blockchain for AI and computational intelligence. All right. So the way this session has been planned is as shown on your screen. So the first part of this session will talk about the traditional centralized systems, what are their disadvantages and advantages, and then we'll move to the second part, which will talk about the use of distributed ledger technology, DLT, for mitigating these challenges that we have with centralized system. And then we'll quickly look at like what are the advantages and disadvantages and the features of the blockchain and smart contract based system. And this pretty much will sum up the first hour of today's session. And in the second hour of the session, we'll talk about what are the issues that we see with the use of these traditional ML and FL techniques, basically the AI techniques, and then how blockchain can pitch in and can solve these issues that are associated with the use of traditional ML and FL techniques. And the second part again, that means the second part of the second hour will talk about the use of blockchain for distributed heuristic algorithms such as genetic algorithms. All right, so pretty much this is the agenda of today's session. So we'll have 1 hour comprising of first 4 parts, and the second hour will be focusing and zooming in, with the use of blockchain for ML, FL, and distributed heuristic algorithms. Okay, so with this, we'll start with the first part. So over the years, the way these traditional systems, they have been designed over the years in a centralized manner, and such systems have years of maturity, and because of that, they have numerous advantages which you can see here. So the first advantage is high physical security, since everything is housed under one location. So such centralized systems are pretty much very secure both in terms of the cyber security and also the physical security, because everything is housed under one location. Then there is no need of multiple infrastructure facility, because you try to build as much as secure and as much as necessary infrastructure, everything under one roof. Then since everything, this is again the advantage of centralized systems, since everything is located and pretty much under one roof, you can easily monitor, maintain, and control them. Then there is established legal frameworks that helps in auditing and compliance, because they have been established over the years, and the legal frameworks are very much in sync with that. And also the market and the business organizations have followed this kind of centralized system, and they also have hierarchical system of organizing, such as you have a CEO and CTO, and then you have different heads and so on and so forth. So it pretty much matches with the centralized systems, pretty much matches with the way organizations have been set up over the years. So these are some of the advantages of the centralized systems. But the thing is that because of this centrality of these traditional centralized systems, there are also some issues that have creeped in over the years, and they are pretty much divided into 2 parts. One is because of the issues related with the centralized nature of such systems, and then the issues due to the third party invocations, right? So let us quickly look at like what are the issues with the centralized nature of such system. So first one is loss of ownership of the data. So once the user has uploaded his or her data on some centralized systems, they are not in control, or you can say they are not having the complete ownership, because although you can keep accessing your data, but you are not sure that if you are the only one who is accessing this, the system becomes a bit of non-transparent, and there might be other entities who might be accessing your data without you getting that notification, right? So you might face loss of complete ownership. Second is single point of failure. There are advantages, no doubt, with the use of centralized systems, which we just now saw. But imagine that if by chance of any exception, if an hacker penetrates in such highly secure centralized system, then everything is at stake, right? Everything, in the privacy of the user, privacy of the data, all the data itself, and all the accessing rights, everything becomes so transparent. So this is the other aspect of having a very secure centralized system. So you have single point of failure. If that system, centralized system, gets compromised, then everything becomes very much available. All right. Then the third part is they are not open and have limited access. You as a user might have an access to that, but it is not open in the sense that it is not transparent. You don't know that what is happening with your data, who is accessing your data, who is somehow utilizing your data in some other way. You don't know that, right? So these are some of the issues. Also, last but not the least, availability is another issue. So you might be, for example, accessing your centralized service such as banking services. So when they have a upgradation going on, you might see that a message flashing on the website saying that there is a server updation is going on, and that is glitch in availability. So centralized systems, because of their nature itself, they might have availability issues because there might be something going on as a patch or repair, or there might be a downtime. So if you do not have multiple facilities, availability would definitely be an issue. All right. So these are the issues that are focused because of that are there because of the centralized nature of such system. Then there are sorry, and then there are issues with the use of third-party invocation. So the thing is that when you establish such a centralized system, at one point of time, you might think that you need some services, and for that, these centralized service owners or the operators, they might invoke services from the third party, which are not very transparent to the users, right? And at times, these third party entities might turn out to be an authoritative entity, and they might get to see all the transactions, all what is going on with the data, and they can even see the data at times, right? So just take an example. Of course, this example is not very precise one, or it's not an exhaustive example, but just take an example. If I have to transfer money to someone sitting in another part of the other part of the world, let's say somebody in Canada, I have to transfer, then normally we use a Swift transfer banking system. So I will request to my bank will in turn request to the other person, that other person means other banking entity, and there is a chain of banks until the last bank which is connected with the user, the transaction reaches to, right? So what would happen is all these entities, they will take their own time of processing your financial transaction, and they will charge some fee. So if there are, let's say, 10 banks which are like existing as an intermediaries, then each of the bank will do some processing and will charge some nominal fee, and ultimately the overall processing fee will be the sum of all these charges taken up by individual banking entities, right? So that is why there is increase in processing delay because of the use of these third party services, and as well as the increase in the fee. So every entity will do some processing which will increase the overall processing delay, and it will also charge fee. So because of the use of these intermediaries, you will have increase in processing delay as well as increase in the fee. So imagine if I have to transfer 100 euros, and if I have to transfer 1000 euros, the fees that I have to pay will be almost flat, because it is not depending upon the amount, but it might depend upon number of entities which are involved. So this is just one example from the banking world, but this might pretty much happen in other cases or in other business operations wherever third parties are involved, because they are going to charge something and they're going to take some time to process whatever business process is there. All right. And last but not the least, although they are processing, these third party intermediaries, they are processing and they are doing the work, but while they are doing so, they get to know the data that you're trying to process, or the transaction that you are going to make, right? So because of that, there would be a privacy issue as well, because normally the data which I am let's say the banking data, if it is there, it should only be shared with my bank, and not with others, and the transaction should only be available to the end user and to me normally. But because of all these third party intermediaries, the privacy, both privacy in terms of user privacy, location privacy, and data privacy, everything can be compromised. All right. So privacy is an issue. All right. So now that we have understood that there are numerous advantages of using centralized systems, but there are disadvantages as well because of the centralized nature as well as third-party invocations. Now, the question is there any technology that can help us overcome these issues that are there with the use of centralized systems? Yes. So in last decade or so, we have seen a lot of hype and people are talking about use of distributed ledger technology, DLT in short, right? So what is this hype all about? And the question is, can distributed ledger technology help us mitigate all these issues of a centralized system? So we'll see together. All right, so let us first understand what is a distributed ledger technology, right? As on date, there is no standardized definition of distributed ledger technology. However, I like the one which has been put up by Financial Conduct Authority, FCA UK. According to this, a distributed ledger technology is a set of technology and solutions that helps you to arrange the data in a distributed fashion. So if you can see in the figure towards the left side, you see that there are different nodes which are participating and connecting uh, and forming a network, and this network is a peer-to-peer network. All right, and whatever transactions that are happening in such system, they are all stored in a ledger, and ledger is a record of activities, record of transactions, and this ledger being digital is a digital ledger, and when it is distributed among all the nodes in the network, it becomes a distributed ledger, right? So the name itself says that there is a ledger which is being shared with all the nodes, and this is exact replica. If any node changes anything in its local copy of the ledger, that should be very much synchronized, and all the other ledgers should update their copy of the ledger. All right, so that is basically distributed ledger technology, where there is a ledger, a digital ledger, which is shared across all the nodes in the network, and this has to be very much synchronized. And also another important feature is all that is being stored in the digital ledger should be cryptographically sealed, right? So distributed ledger technology exhaustively makes use of cryptographic techniques. Why so? Because this environment is a distributed environment where the nodes can be rouge. That means nodes can be malicious. They might try to update their local copy of the ledger in a malicious way because it might benefit their connected users. But if majority of the nodes in the network are are the genuine one, then they will not be able to update this ledger. And also, since this is cryptographically sealed, everything is cryptographically encoded, it is much more difficult to directly go and update that ledger. All right, so let's come back to this definition. So it is a set of technological solution. We'll see very soon that that a blockchain is a most popular type of distributed ledger technology, and we'll see that the blockchain is a mix of uh, different technologies. So that is why it says that it is a set of technological solution that enables single sequence standardized and cryptographically secure record of activities. All right, okay, so summing up all, the the distributed ledger is the heart of distributed ledger technology. And this ledger is shared among this peer-to-peer decentralized network. Why it is a decentralized network? Because every node is an independent node. That means all these nodes may belong to a different a vendor or a different operator. There is no one authority who's controlling all these nodes together. All right, so that is why they are decentralized, they are independent nodes, they are all working towards they are all working together to reach to a common consensus. And what is this consensus? The state of the distributed ledger. All right, so this ledger has to be immutable. Why? Because no malicious node should be able to update this node, update this local copy of the ledger. If they update anything in the local copy, that has to be synchronized with everyone. And if it is not legitimate update, every other node should reject that update. All right, so because of the use of cryptographic techniques, this ledger is immutable. It is shared with all the peer nodes in the network. It is synchronized. Any update in, let's say, copy of any node if legitimate, should be replicated at all the other copies of the ledger. All right, and finally it is cryptographically sealed. All right, now that we have understood that distributed ledger technology is a kind of a system where there are peer-to-peer nodes which are connected, forming a decentralized network and maintaining a ledger which is distributed exactly among all the nodes. Now let's try to understand what are the different types of distributed ledger technology. Okay, so most of the time I've seen like novice or people saying that distributed ledger technology is blockchain and blockchain is DLT, and they use both the terms interchangeably, whereas the fact of the R is that DLT is a big umbrella under which there are different technologies, and blockchain is just one of the types of distributed ledger technology. All right, so they are different. However, because blockchain is very much dominant as a DLT technology, people, knowingly or unknowingly, they are making use of two different terms interchangeably. All right. Okay. Now let's try to see what are the different types of distributed ledger technology. The first one, as I mentioned, blockchain. So blockchain is one of the most popular type of distributed ledger technology. It came in the year 2008 with the advent of Bitcoin cryptocurrency, right? And in fact, this technology is one of the examples where the use case appeared first, and then people realized that the underlying technology is something much more interesting and it can be applied to the other domains, right? Why I'm saying this is that in the year 2008, a pseudonym named Satoshi Nakamoto, he launched a cryptocurrency named as Bitcoin. Now everybody knows what is Bitcoin, right? But before 2008, nobody knew what is blockchain technology. And there was this launch of a Bitcoin cryptocurrency in the year 2008, and then people didn't bother about it, and the first transaction happened in the year 2009, and gradually people understood what is this cryptocurrency is all about, that it is ripping off the centralized system and giving you a more peer-to-peer system of transacting monetary values. And then when it gained popularity, people thought of understanding what is the underlying mechanism or what is underlying technology, and then they realized that the underlying technology is something much more interesting than the use case itself. And then people found that, okay, this is interesting technology, and then they gradually the name came up as a block of chain of blocks, and later people named as blockchain, right? So 2008 marks the advent of blockchain. Then there are other types of distributed ledger technology such as directed acyclic graph, DAG. It came in the year 2017. It uses a structure, as the name itself says, it uses DAG as a structure of storing transactions. Then there is another one which is Tempo, and I'm just giving you few names or few types of DLTs, but there are others as well. The Tempo came in the year 2018, and it uses an object called as atoms. And then you also have as Hashgraph, which is another very popular type of DLT, and it uses mechanism which is called gossips about gossip and virtual voting, launched in the year 2008, right? And there are many more. So I am just giving you an idea that there are a lot of different technologies which are covered under the umbrella of DLT, and blockchain being the most dominant type. All right, now that we have understood that blockchain is a type of a distributed ledger technology, let's try to understand what is blockchain. And the word itself, as the distributed ledger technology, says a lot about the technology. The same way, the blockchain also talks about what is this technology about. All right, so what is blockchain? Let's try to decompose this word into two, block and chain. So what is happening is this. So there are a lot of transactions that happens during a period of time, and let's say this period of time is 5 minutes. So all the transactions that are pushed into the system within this 5 minutes, they are all clubbed together, and a logical unit is created which is called as block. And block is nothing but a set of transactions which are clubbed together, and a logical unit is created. So this is a structure which is holding a set of transactions that appeared during 5 minutes of duration. All right, and this 5 minute is just an example. For Bitcoin, it's 10 minutes. For others, it could be 15 seconds or something, and so on and so forth. But this is just an example. So you take a unit of time, which is actually a time frame, and what all transactions appear during this time period, you club them all together and create a structure, a logical structure, which is called as block. Now, as the time passes, there are more transactions which are pushed into the system, and they are all again clubbed up together, and then a new blocks are created. So this new block is connected with the last block in the chain of blocks, and this connection, as you can see here, is a logical connection. It is actually a cryptographic connection. So what is happening is, every block, when it is created, it is like cryptographic technique, which is called as hashing, right? So every block is hashed, and the hash of that block, so when I say every block is hashed, actually the header of the block is taken, and that header is hashed, and you get a hash of block's header. So every block has, you can say in general, that every block has a hash value, and whenever a new block, right now on your screen you can see a block which is having a background as red color. This is recently created block, right? This block is supposed to be changed with the latest block in the chain of blocks, which is towards the left one. All right, so what you do is, you take the hash of the last value or of the last block, and you put that hash in this recent block's header, one of the fields in the header, right? So if you have one more block which is, let's say, created after this block, within a span of 5 minutes, what all transactions come up, you again pack them together and create a new block and connect this new block with the latest one in the chain of blocks. How? By taking the most recent block's hash and putting that hash in the current newly created block's header field. Okay, so one of the field is previous block hash. So I know, like, if you are listening about, or if you are studying blockchain for the first time, all that you have to understand is that blockchain is a chain of blocks. What is block? It's a type of a data that you are conceptually using to bundle up together all the transactions, and then all these blocks are connected together. How? Logically, using what? Cryptographically hash-based chain. All right, good. So since it is a hash-based chain, it is kind of much more secure, because let's say if the hacker tries to change even one bit of any block, right? Then if you change one bit, if the people from the computer science background, they know that if you change even one bit, which is input to a hash function, the entire hash value will change. So if that hash value of the block will change, then the next block headers field, previous hash block, will change, and this kind of ripple effect will destroy everything. So if even hacker tries to change one bit of one transaction in one of the blocks, all the series of blocks after that will be rejecting that change, because that is not in sync. All right. Okay, so now that you have understood that blockchain is a chain of blocks, let's try to understand then what is blockchain. Is it a technology? Is it a data structure? There are a lot of ways you can understand. So let us try to quickly understand different aspects or different way you can look at blockchain. So first one is distributed ledger technology. So blockchain is a type of a distributed ledger technology where the ledger holds all the transactions, and these transactions are secured and they are distributed because it is a distributed ledger, and they are all cryptographically sealed, right? So what is blockchain? It's a type of distributed ledger technology. Now, the second viewpoint is a data structure viewpoint. So I told you here that there are different structures that you can use. So here in blockchain, the structure is chain of blocks. In the DAG, it is a DAG structure that you are using, right? Similarly, so what is blockchain? So how blockchain is different than DLT? So blockchain uses a specific type of a structure to arrange all the transactions that have pushed into the system. So this structure is again a series of blocks which are all chained together using a hash-based chain, right? So transactions are bundled into a unit called as block, and then blocks are linked together. So what is blockchain? It's a specific type of data structure to collect and to arrange all the transactions which are cryptographically sealed. All right. Now, another viewpoint, normally you would see people will say blockchain technology, right? So why it is called technology? Because blockchain itself, as I mentioned a little time back, is that blockchain or a DLT is a mix of technologies. So the interesting aspect about blockchain technology that there is nothing new in this technology. It is actually a powerful mix or amalgamation of all the existing technologies that people saw in a couple of years before the advent of Bitcoin cryptocurrencies, right? So it's basically a technology which itself is a mix of underlying technologies, right? So for example, there are a lot of cryptographic techniques that are used in blockchain, which is such as PKI hashing, digital signature, Merkle tree, and so on and so forth, times stamping and all. Then you have another technology which is peer-to-peer networking, which you might know if you have heard about file sharing system, let's say BitTorrent and something like that. So that peer-to-peer technology is used to connect all the nodes in a blockchain network. And then you have consensus algorithms, which are driving another set of techniques, which are ensuring that there is exact one state of the ledger right at any given instant. If let's say half of the nodes in the blockchain network is having a different state and other 50% of the node has a different state of the distributed ledger, then it does not make sense. They will not all say the same point, or the thing is that they should have the exact or the same state, right? For that you need a consensus algorithm, and these consensus algorithm allows all the nodes at any given point of time who are participating in the blockchain network to reach to a common agreement. All right. And then you also have different kind of economic models which are driving such blockchain network, because as I said that blockchain is a decentralized network. There is no one authority who is controlling all the nodes which are participating in the blockchain network. There are nodes having of course there can be pool of nodes, but that's a different story. But every node has a separate owner who is owning that node. So all nodes are not belonging to any particular organization or any particular group. So the thing is that if I am tomorrow coming as a one node and trying to participate as a miner in a blockchain network, then I need to be incentivized. Why should I come and join the blockchain network? So let me just quickly clear up this thing. So if you have a traditional banking system, you have your bank and you pay some amount of fee for for using ATM or for using internet banking, something, and so on and so forth. So that banking system is being incentivized based on what money you are storing there. They are again investing your money, giving it a loan, and they're getting revenues out of it. So that system is centralized system, and there is economic model which is driving it. But imagine nobody is having a control of all the nodes, and these all nodes are having different owners. So who is going to pay them? That means who is going to incentivize them to participate in the network? So for that you need to have economic models to incentivize these nodes. So the thing is that I'm giving you a broad picture of blockchain technology. If things are not very clear, that's pretty much fine if you are hearing it a first time. But the thing is that at least these things will help you understand better, and then after this FDP you try to get in touch with blockchain technology by reading papers or books. It will help. All right. Okay. So now we are done with the brief introduction about blockchain. So blockchain is the most dominant type of distributed ledger technology. It uses different technologies, mix of technologies to come up and to give you a blockchain technology. And again, blockchain is a dominant type of DLT. Now let's try to quickly look at smart contracts. What are smart contracts? These days, So blockchain has different generations. Blockchain 1.0, 2.0, 3.0, and 4.0 is probably running right now. So smart contracts, they came into the picture during blockchain 2.0 generation, right? With the evolution of Ethereum, blockchain platform. So let's quickly understand what is smart contracts. And there is interesting and funny part about this smart contracts, which I'll just now share with you all. So what is smart contract? So a smart contract is very simply stated, it's a codified version of a contract. Let's say there are multiple parties who are entering into the contract. Today we have, let's say, when you go to a court and you sign a contract, it's a paper based contract, right? Now if all the terms and conditions of these contracts, if they can all be codified, and you can create a software code out of those terms and conditions by codifying them, then that is called as smart contract. Now, as I said, that there is interesting fact about smart contract. So smart contract was designed long before the advent of Bitcoin. As you can see in the second point here, the concept of the smart contract was conceived by Nick Szabo in 1994, and Bitcoin or blockchain, you can say, came into the year 2008, right? So the thing is that smart contract is not necessary to be deployed always on top of blockchain. It can be deployed in a centralized system as well. But if you want to get the maximum out of it, sorry, did it even say something? No? Am I audible, by the way?
Yes, sir, you are audible.
Okay, great. Right. So the concept of the smart contracts was given long before, as I said, by Nick Szabo in year 1994. All right. So smart contracts need not to be always deployed on the top of smart contract on the top of blockchain. They can be deployed in any server. But if you want to leverage the maximum benefit of smart contracts, it is better to deploy on a decentralized peer-to-peer blockchain network, right? So a smart contract is a computer program that encodes all the terms and conditions of any legal contract, and then it can be deployed on top of blockchain network if you want to leverage maximum benefits. All right. So another interesting part of smart contract is it contains predefined states or predefined conditions. So when you encode or when you develop a smart contract, you can define some conditions that might happen in future any point of time, right? And then you deploy this smart contract on top of blockchain, and in future, if those conditions are met, these smart contracts are automatically triggered, and they can execute those desired operations automatically without intervention of any external body or any external entity. All right. So smart contracts can be executed automatically, and that's why the biggest advantage of combining smart contracts with blockchain is bringing decentralized autonomy. And then you can create something which is called as decentralized applications, DApps. Okay, now let's quickly look at what are the salient features of the blockchain. If I use, what are the advantages? In other words, if I use blockchain, what are the advantages of blockchain? Or what are the advantages if I'm using blockchain for my system or for my business process? All right. Okay. So the salient features of the blockchain technology are, the first one is decentralization. The most important one. We started this session by discussing centralized systems. They have advantages, but over the years, the problem is decentralized systems have numerous disadvantages as well, because of the use of third-party intermediaries or because of the centralized nature of such systems. Now comes the blockchain technology, which is a DLT, a type of a DLT, and it provides decentralization. Many a times it is a bit difficult to understand what is decentralization here. So decentralization basically means that there is no one authority who is having the control or the sole authority of making decisions or of creating new data or new content in the system, right? So here, as I said, that blockchain is created by nodes which are connected in a peer-to-peer fashion, and any node is equally capable of creating a new block and adding to the existing chain of blocks, existing distributed ledger, that means, right? So any node is equally capable. It can decide whether this block is right. If that block is right, it will add that block to its local copy of the ledger, in the local copy of the ledger. And if it is right, it will broadcast to every other node in the network, and they will in turn verify that block. And if that block is correct, is legitimate, they should also add that block to their local copies, and that's how the entire network is synchronized, right? So that is what is decentralization. There is no one authority who is in control of everything. Any node is having equal capability to create new block and add to the blockchain. All right, the next one is enhanced security, and this comes because, as I said, that blockchain itself is a mix of technologies. It exhaustively uses cryptographic techniques, and whatever the best is available, it tries to use those cryptographic techniques, and everything is cryptographically sealed. So because of that, it has enhanced security. Then immutability, I explained that with the help of the example where if you change one bit in any one of the transaction in any one block, so every block has set of transactions. If you try to change even one bit of any one transaction of that block, then the hash of that block will change. If that block's hash will change, then the next block should hold this block's hash. That will change. If that change, the entire blockchain, and this change will ripple down to the last block in the blockchain, right? So it is. So there are two reasons I should say why the blockchain is immutable. First one is that it is cryptographically sealed, and the second one is the network is decentralized. If you want to completely change an existing blockchain, then all the nodes should do the exactly same change. Then the change will be registered. If you try to hack one node successfully and you try to change all the transactions in the local copy of that block, then also it will not happen. Then also that change will not be replicated to all the other nodes. All right. So because of the decentralized nature and the cryptographic techniques used, the blockchain is immutable. And rather, I would say that this word should, the better word should be temper resistant instead of immutable, because we have seen that there have been a lot of attacks on blockchain, especially coming from the cryptographic world. But that is a separate type of a blockchain, which is public permissionless type of blockchain, and there the attacks might be possible, yes, but only if you try to have a very high computational infrastructure with you, and you are able to hack at least more than 50%, at least 51% of the total nodes participating in the blockchain network. Only in that case you will be able to uh, mutate. Or else if you try to change any one node's blockchain, that is ledger, then that change will be very well noticed by all the other nodes, and they would say that there is some tampering going on there. Let us discard whatever updates is coming from that node, and they can label that node which is producing illegitimate transactions or um, you know uh, malicious updates. Then you have another advantage of blockchain technology, which is called as transparency with pseudonymity. Now this is interesting. When you say transparency, it should mean that everything is visible to everyone. Yes, if you talk about public permissionless type of blockchain, then all the transactions that are happening in a blockchain network are pretty much visible. You can see everything that is happening. Let's say an example of public permissionless blockchain is, let's say, Bitcoin, or let's say Ethereum, right? So if you try to see the logs of all the transactions, anyone can see. But all that you can see is that there is transaction happening of, let's say, some monetary unit. If you talk about Bitcoin, let's say 0.5 BTC from this address to this address, from this address to this address, some transaction, right? So although you can see everything that is happening in the system, even if there are some smart contracts deployed, then also you can check that these are the smart contracts which are deployed. However, the thing is that why it is called pseudonym system is because that there is a transaction happening between public address A and public address B, but you don't know to whom this public address A is belonging to in the real life. So that connection of real life entity and the digital identity in the blockchain system, that link is missing. Because of that, the system is although transparent very much, but still there is pseudonymity offered by the system. Okay. Then fast overall processing, because you are ripping off all the centralized entities. There are no use of third-party intermediaries in the blockchain-based system, and because of that, the processing delay that was incurred by each intermediaries or each centralized entity, that's not there. Once your transaction is processed by any node in the network, it will quickly get accepted by everyone if it is legitimate, of course, and because of that, the overall processing delay will be reduced and you will have fast processing. Then non-repudiation, which says that if you have committed something in the system, that means if you have made any transaction, tomorrow you cannot deny that no, it was not me, it was not me, I didn't do that transaction. That's not possible, simply because of use of cryptographic techniques, and this is a digital signature. So everything that you are pushing into the system is signed with your private key. So you can very well identify who is sending the transaction, whether it is coming from that particular user or not. Then there is consensus based validation. As I said that all the nodes should reach to an agreement that this is the new node, new block, and this should be updated by everyone. So you need a consensus algorithm to ensure that everything is very much in sync and intact. And there are different type of consensus algorithm. There are voting based consensus algorithm, and there is a puzzle based consensus algorithm, like for example proof of work, which is very much popular. And then last but not the least, the use of smart contracts enables, as I said, decentralized autonomy, right? So if a smart contract is designed and deployed on top of blockchain and everybody has agreed to that terms and conditions, then in future if anything happens, then the smart contract will automatically be executed, and the system can be automated. There is no need of any entity to process or trigger that transaction. All right, so with this we are done with the part 1, which is about DLT, centralized systems, then DLT, blockchain, and smart contracts, and salient features of blockchain smart contract enabled system. Now we'll be moving towards the second part, which is blockchain for AI, specifically blockchain for ML and FL, machine learning and federated learning techniques. Do we need to take a break here at this point of time?
Yes, sir.
Okay.
Yeah, we can take a break for 10 minutes and thereafter we will start the part 2.
Okay, great. So we'll resume at about 5 past 8.
Fine. Okay.
Okay, great. Thank you. Yeah, please let me know when I can resume.
Yes, sir, you can start.
Okay, fine. All right, great. So now that we have a bit of you know understanding and background about what is blockchain and what are the advantages of using a blockchain and smart contract enabled system, now it is time for us to look at you know different AI techniques. Specifically, because of the time constraint, I would talk about two specific AI techniques: ML, machine learning, and federated learning, FL. And we'll try to see, like, for each of them, what are the issues that are there when someone is thinking about using ML and FL techniques, and then what could be uh, alleviating role of blockchain technology to overcome those challenges or those issues. Okay, so that's the aim of this part. So AI, ML, deep learning, data science, and big data, they are now emerging, and the fact of the time is, or the what should I say, like, because of their rapid emergence, it is becoming difficult to to understand and to draw a line that what is AI and what is ML and what is DL. And if you talk about even computational intelligence, then how they are different, because many places I see, like, computational intelligence being said as nature inspired or bio inspired, but at the same time I see, like, ML being integrated when they talk about. So the thing is that there is very thin line differentiating different AI techniques, I would say, or computational intelligence technique. Here, let's talk about AI, ML, and deep learning techniques. So AI is like a big family. So in simple words, AI, or artificial intelligence, is a way to make machines intelligent. More specifically, it signifies intelligent computer programs, right? We can put it like this. Whereas, as you already know, like, machine learning is a subdomain or a branch of artificial intelligence which can process data and provide feasible solutions to complicated problems. Okay, in short, maybe we can say that ML ML trains computational models using statistical methods and data. ML techniques are usually categorized in three, or at times four, different categories, as you all know, like supervised learning, unsupervised learning, semi-supervised learning, and reinforced learning at times. And whereas deep learning, as you can see, is a subset of the machine learning, as I understand from this figure. The source is at the bottom of this slide. So the deep learning can be said as a subset of machine learning. In deep learning techniques, artificial neural networks and algorithms inspired by human brains learn from large amount of data, right? So here, I mean, deep specifically means many layers, right? So they have multiple layers. So uh, so the crux is that there are different types of AI techniques and ML, and now there is another circle I would put here, if I'm allowed to do so, which is federated learning, which is kind of a distributed AI, which we'll see in some time. All right. So let's talk about first machine learning techniques and their associated issues, right? So machine learning, we all know, as I just said, that it is a technique in which you have if you have a model, and there's a training process which is trying to train that model, and usually these models are trained at a centralized servers, and for that you need training data which are sensed by different sensors or devices, and they are all collected at this centralized server. And then these models are trained, and once you have a trained model, that will help you to better make decisions and intelligently reach to better conclusions, right? So that is the basic traditional ML technique. So that the crux is that if you have more training data, you are better off with predictions, and you have intelligent decision makings possible. and the model becomes more reliable and it gives you the required results, right? However, what are the issues? That's the important part where the blockchain can come in, right? So let us focus on the issues with the traditional ML techniques. The first one is resource constraint. So one, if you normally, let's say if you are talking about IoT, ML enabled IoT system where there's machine learning at a cloud at a cloud server, the ML model is being trained, and you have IoT devices which are sensing the data, and all these data has to be, you know, aggregated and collected at this centralized cloud server. Then if you talk about, if you think about these IoT devices, they are resource constrained. They have limited battery life, and they have limited storage. So the more data, better the model can be trained. But for more data, you need more resources, and the resources are actually less available with these IoT devices. So this is the first issue. The second one is the communication cost. So if you want more data, then more data needs to be transmitted, and then more networking resources will be required, right? So the cost of communication, that means use of bandwidth and network resources and networking services and connecting devices, blah blah, and so on and so forth, the cost will increase if you need more data. Another issue is the processing overhead for gathered data and then organizing them, and then ensuring whether all these data are uh, are right in terms of security compliance, right? So all these are the issues with the traditional centralized system. However, the interesting aspect is there are also issues which are related to the centralized nature of these traditional ML systems, right? As I said just now, that normally the model training happens at the centralized server, and these centralized servers are are having the issues which any centralized system have, right? There can be single point of failure. If this server where the model is being trained, if that goes down, or if that server is compromised in terms of security, or if that is being hacked, then your trained models, not just your trained models, all the data, and this could be having some personal information attached with that data. So all that is at disposal of the hacker, right? So there is a single point of failure. Then, as I mentioned, security threats. Now these security threats are not just in terms of privacy leakage or the data security point of view. They are also in terms of you know, if there are malicious what you say, if they are malicious data pushing devices. That means if I want to make sure that your data does not train well in the right direction, I want to poison your model, then I'll be pushing malicious data into your system, right? So this malicious inputs coming from different fake identities, or the nodes which are compromised, right? They were genuine before, but they are now under the attack, and the hacker is controlling the data being pushed by these nodes. So the thing is that ultimately you will have poisoning of your poisoning data, and then it will corrupt the model ultimately which is being trained, right? Because of the centralized nature. If there are, imagine if there is not just one server, if there are thousands of servers where the model is being trained, then it becomes much more difficult to poison that or to attack that server, right? So single point of failure or the security threats will go down exponentially. And the last but not the least, privacy leakage. And privacy can be all different types, data, location, or identity privacy from all the collected data, right? So the crux is you have centralized servers, and then all the data that is being pushed to the centralized server, they might have personal information as well, right? So if that data is compromised, if somebody attacks that server, then everything is at stake. All right. So these are the issues with the use of traditional ML techniques. So what is the crux, or what is that you can understand as an essence of this discussion? So the thing is that it is with the increasing smartness and with the increasing complexity of these ML techniques, it is getting very difficult to establish and maintain trust. And more to that, if if you have to comply with some auditing authorities, then it is much more difficult, because there is less transparency in the way your model is being trained. So all the data is being pushed and model is being continuously being trained, but tomorrow there are no evidences available that what steps per year, at what point of time, how was your model, and then later at some some point ahead in time, how your model was changed and what were the data that were put into it. Is very difficult with the traditional centralized systems, and that's why auditing and compliance becomes another very difficult task to ensure. All right, so now that you have a bit of understanding of what are the issues with the traditional centralized traditional ML techniques, let us try to see a specific specific scenario of ML IoT enabled system, and what are the security threats in such system, right? So here you can see that there are different IoT nodes at the top layer, and these IoT layers, IoT layer, or the nodes in that IoT layer, all the IoT nodes, that means, are pushing the data to a centralized cloud server, right? And this data is getting stored there. Let's not talk about the first the threat vectors, just understand the flow. So all the IoT devices are sensing the data, they are pushing it to this centralized cloud. But because of the resource constraint nature of IoT devices, you cannot employ normally, or usually it is very difficult to ask them to and to do encryption and everything. Everything is cryptographically sealed. That is not possible because of the resource constrained devices. So normally these data are pushed to this centralized cloud in plain text. They get stored in there in plain text, and then the data is stored or received is then pushed to this process, which is a training process, and you give an input this data as an input to this training process, and ultimately you get a trained model, and which you can use to query and to reach to a intelligent decision. Right now, let's turn our attention to different, and these are just some of them, right? So what are the different security threats that may happen because of the plain text nature and because of the centralized nature of this cloud, and model also being trained at this centralized cloud server? What are the threats? So you can have eavesdropping. That means somebody just listening to it, and then later on you don't know what kind of inferences they can right. So that eavesdropping is one. Another one is impersonation, where somebody is trying to pretend as somebody else and trying to get access to your system. Then somebody can try and get your identities, and later on maybe use your identity to some other system that or services that you are using. So that can be another threat. Then you have data tampering attack. You want to tamper the data, or you want to manipulate the data. There might be different reasons of doing it. Maybe you want system not to be accurate, or you want exactly system to behave in a way which is which is uh, uh, which is as per the attacker's plan, right? So there can be multiple reasons why you are tempering or manipulating data. You want a model to be trained in a particular way so that it gives advantages to the attackers. That is one reason. Another is just to corrupt the model so that it never reaches to it. You don't want model to be trained accurately, right? And then there can be linkage attacks, where you try to get the output and try to infer that what is the link between that, and then you try to get the insights about the training process itself, like what algorithm, what process is being used to train that model. Okay, and then there can be inference attack from the query and from the input as well. Okay, so looking at this, we understand that the use of you know traditional ML techniques can have a lot of security threats, as well as all these data are being pushed here at a centralized cloud server, and because of that there will be issues in terms of privacy, and which is big concern nowadays, because every country and every continent is coming up with their privacy law. India also has recently come up with its privacy law. There is a GDPR with the European Union. Then there is a California Act with the USA, and there are different privacy policies that are coming up these days. So if your system is not complying to these privacy privacy laws, then there can be there can be very severe repercussions of your services or the services that you are providing. Okay. Okay, so now that we have understood the issues, now let's try to map, or let's try to understand how blockchain technology can help overcome these issues for the traditional ML techniques, right? Okay, so towards the left, this is very interesting paper. I would recommend all the attendees to, if you really want to get insights about the use of blockchain for ML technique, this is very interesting survey paper by these authors, and this is in IEEE Communication Survey and Tutorials, a very reputed journal. So these are the features or the advantages of using blockchain technology, of course, in conjunction with smart contracts. So you have shared, transparent, and distributed ledger, which I mentioned, immutable, irreversible, and auditable records. Then you have decentralized peer-to-peer network of nodes, and every communication is peer-to-peer, and everything is secure, cryptographically secure. Then you have secure sequential and timestamp data, and then you have consensus-based updating. No one entity can directly update the overall ledger. Everybody has to reach to a conclusion, and then only the majority consensus will be there, and then the ledger will be synchronously updated. All right, so these are the features of the blockchain. And then now let's try to understand what are the benefits that we can leverage when we think of using blockchain for traditional ML techniques. All right, the first one is data sharing. So as I mentioned here, that when you are sharing this data is at times it's usually a plain text data. Also, now the thing is that even if, let's say, you say that IoT devices these days are getting powerful, they can do the encryptions. Even though they do encryption, the thing is that there can be impersonation, there can be malicious IoT devices pushing up the wrong or falsified data for the training. So what you want is that every data that is coming to this to train this central to train this ML model, this data should be secure. This data should be secure in the sense that there should be non-repudiation. Nobody should deny later on that this data was not pushed by me. That should not happen. So all the security features, if you use a blockchain, then IoT devices or any other node which are sending the data, they can be blockchain clients. They can be blockchain users pushing up the data to not just, so this centralized server where the model is getting trained, instead of this centralized server, there can be a peer-to-peer blockchain network where the data is getting pushed, and they together are trying to train. So you can have the split of resources. The half of the resources is going towards, I'm just saying that some portion of the resource, not just half, some portion of resources can go towards the building up the blockchain network, and the remaining resources can be used to train the model as well, right? So that is one possibility. Then so the another thing is model sharing itself. How it can be done, we'll see in some time. So users can control their data, right? As I mentioned, then when there is a centralized system, once you push your data, of course the data is being used to train this centralized ML model. But is there somebody else who is eavesdropping and trying to access your data? Although it is used to train the model, but is there somebody else who is accessing the same data but making use somewhere else out of the context? So do you have the complete ownership of your data? If not, use of blockchain will allow you to ensure that you have control ownership of your data, and the model can be securely trained. Then of course, when you have strong security and privacy, then so this and privacy is coming from the point of the process of process of model training, right? It's not about the data. So data security and data sharing we have discussed. Now let's say your model is getting trained, but the model is getting continuously trained, but can it be possible that you can give an evidence, or you can give the proof of how your model was getting trained? So can you give you know how you can say that, can you give the auditability of your model getting trained in the right way? What were the important steps that were involved? How your model was trained at after 1 hour, let's say, or after some unit of time? Can you log that thing in your system? So if you can log that, then you can provide the auditability of the training process itself, so that in other sense it is building trust for the model getting trained, right? So normally, if you talk about traditional ML systems, the centralized server is training the ML model, and that you have to blindly trust. You cannot ask, or the authorities will find it difficult to audit the training process itself and establish a trust among the users. So with the use of blockchain, you can do so. Then you have decentralized intelligence. There can be ML cloud, right? There can be ML cloud, in the sense that the decision making is not just done by one entity. There can be a lot of different entities who can collaboratively decide on making a decision, right? So there can be decentralized intelligence, and you can have a distributed ML model based decisions. Okay, and then ultimately the trust for decision making. So if you have immutability, if you have a strong security and privacy, and everything is getting logged, and you allow the users of the system to see and to verify all the training process or the steps that were involved and the data that were used. So ultimately you are building up the trust in the system and the decision it is making. All right, so that's how you can make use of blockchain for traditional ML systems. So now that we have understood the use of blockchain for machine learning techniques, ML techniques, the interesting one, and which is now emerging, is federated learning, right? So this is getting much more traction now, and people are trying to do more and more research in the FL domain, and also the interplay of blockchain and federated learning techniques. So what is the difference between ML and federated learning, right? That is ML and FL. So a quick recap. So traditional AI techniques, that means traditional ML techniques, what they have centralized data collection. All the data gets collected at one place, and then training model at a centralized server. So if you look at the overall system, it is very much centralized, right? So imagine all the users data is collected at one point, and if that one point gets compromised, every data is like your system is actually collecting all the data and giving it to the attacker if the attacker gets success in penetrating your system, right? So that's the first problem, or that's the issue with the centralized nature of traditional AI systems. Then sensing, communication, and collection of raw data. Now this raw data is problem. So all the data that you are sending to the centralized server, they are all raw data. Even if you are not polluting or not poisoning or not manipulating that data, you can look, you can see that data, you can store that data at somebody. As an attacker, I am talking about, an attacker can see the data and can fetch that data, and then apply different techniques to infer uh, you know uh, different informations by doing a lot of different techniques. They can find out the privacy information which are somehow hidden, so they can infer, and this leads to privacy issues. So so the point is that if everything gets collected at one place and this all data is raw data, then privacy definitely is an issue, right? It can give a lot of information, uh, irrespective of what is useful for that central uh, train model. All right, so that's an issue with the traditional AI techniques. So to mitigate these issues, uh, lately the concept of distributed AI has come up, and FL is one of the interesting type of distributed AI. So what is distributed AI? So distributed AI is actually argumenting that the argument is that nowadays even a smartphone is very powerful, right? There are a lot of resources. uh, if you not talk just about very resource constrained devices in general, the devices, these mobile devices, not just mobile phones, but these mobile devices like Raspberry Pi and all, they are very powerful these days, and they can do not like very intensive computation, but they can still do uh, a, a significantly good level of computations, right? So if you have these powerful, I mean, not resource constrained devices, right? Then how about this? Instead of sending the raw data to these centralized servers, these all devices, they locally train the model using their locally sensed data. So one more time, instead of sending all the data from these devices at one centralized server, how about not sharing this data? All these mobile devices, whatever data they are having with them, they locally train their model. They locally train that shared model, right? This local model is also called a shared model. So they locally train as per their computational resources, whatever they have at their disposal. They will locally train that model, and then they will push only the model updates. And because of the updates, the differential updates are small, the computational cost of sharing that updates are small. And it is not about this update. So let me just come back to first what is distributed AI, which is FL, federated learning. So all these mobile devices, or these so-called not resource constrained devices, they are locally training these models. And then once they are done with their round of training data, because this training will happen in multiple rounds, might keep go on and on. So so in any given round, they will have some model updates, and they will only push this model updates to this centralized server, which is called as aggregation server. And the job of this server will then be to come up with a global model by aggregating these all model updates. So what is an advantage here? So this is what is called federated learning, where the model is not trained at one location. All these devices are taking part, are participating in creating a federated environment, and they are locally training the model, and only the model updates gets pushed to this aggregation server, and that server is going to come up with the globally trained model, or the global trained model, right? So there are local models, locally trained models, and globally trained models, and globally trained models are much more accurate, right? So what are the advantages? So all these issues that you see, so all these issues which you see with with the traditional ML system are resolved. You are not sharing anymore the data at the centralized server. So privacy, the biggest advantage is privacy is intact, and all the attacks that you were placing before, while the data gets transmitted, they are now out of scope, because data is not being aggregated at one server. Only the model updates are this. And if somebody, now the attackers try to get some model update, one or two updates, then those model updates, few of them will not help the attacker to come up with the global model, right? The attacker should be able to get all the model updates, and in addition to that, it should also get the algorithm which is used to train or which is used to aggregate all these updates, right? So that is what in short is the concept of federated learning. So federated learning leverages on device processing power provided it provides privacy protection and saves the network bandwidth, because now you just have to send the updates, not just the complete model, also just the updates and not the complete set of data which usually is pushed with when you talk about the ML landscape. All right. Now, having said that, let's quickly understand how this works. So you have in the gray cloud, you have a global model, and then you have the good updates and the bad updates, which we'll understand quickly. So the first step is so interesting figure. The source is at the bottom of the slide. So here you see that all the central server, it will distribute whatever the latest copy of the global model they have. So this is like the first the first model that if it is just booting up, the process of training is getting booted up, then it's any raw update, raw model, or it can be like at any intermediate state we are looking at the process. So whatever this central server has the global model, it will share with all these devices. Then these clients will train the global model with their local data set, and they will so so first of all, the central server will distribute the copies of the model to each of the client. Then the client is going to use that global model and train that global model locally using their local data set, and they come up with what is called as gradient updates. Only the difference of what updates have been done. Normally it's like the update parameters are being shared, right? And these update parameters are then pushed to the centralized server, right? And now the thing is that if there are now we are moving towards if there is a federated learning and if there is a pernicious client, that is malicious client is there, then what it will do is it will try to update the global model with the illegitimate data or whatever the way it wants, and it is pushing up here. And then you also have the client here, and it updates that, and then the central server model will just create the global model via the aggregation or federated averaging, right? Now there can be a lot of things that we can talk here, but because of the time constraint, I think we'll go towards the use of blockchain for federated learning, right? So very interesting paper, this one, which is trying to make use of a blockchain for federated learning when you talk about edge computing, right? So nowadays, I believe at least the people, because I believe this there may be participants from the chemical engineering background and other backgrounds, and also computer science background. So I'll quickly give a brief idea about what is. Everybody today might know cloud computing, right? Amazon has its cloud services, Microsoft Azure has its cloud services. So these are all cloud services which are located at logically they are centralized, they are located at one place, and normally the server might not be very close, right? but but recently the concept of MEC, multi-access edge computing, it has come up, and what it is trying to do is that miniature version of the cloud is moved towards the edge of the network. That means you have a base station, it could be node G, or I mean depends upon what generation of mobile networks you are talking about. So you, along with the base station, you can have your you can have close by a MEC server, which is a kind of, you can think of resources that are available with the cloud, but not in that uh, you know in that strength. So it has a miniature version of the infrastructure available at every edge of the network, right? So if you want, you can think of like your mobile phones reaching to the base station where your signals reaches there, and associated with that or close by to that BTS or base station, you have a MEC server. And if this MEC server is not capable enough of processing your, because they don't have as powerful infrastructure as a cloud has. So if they are not capable, then they might reach another hop to the cloud computing. But most of the time, these are significantly resourceful servers, and they can process your request, and it can get most of the time. So what is the advantage of bringing in the edge computing as compared to cloud computing? The advantage are many. The first advantage is that you don't have to go all the way to the cloud computing server, which might be located other part of the country or other part of the world, right? It is very much close by, and it's just normally one hop or two hop away, and you have your MEX server and process, and you quickly get the updates from the MEX servers, right? So now that you have a brief idea about this figure, so you have mobile devices, you have mobile antennas or BTSs, and associated with that you have a MEX server, which is a kind of a miniature version of a cloud computing server. All right. Now let's try to understand federated learning architecture here. So you have your again. So what I'm trying to do is, if this is very generic scenario, and more realistic scenario is with the mobile devices. You have your smartphones, and they are pretty much very powerful these days, and you have your MEX servers close by to your base stations. So let's say base station is that centralized server where the global model is computed. But before the global model is computed, your local devices will do the local training. So there can be multiple rounds of the training. The MEX server select the few subsets of the devices. There might be n number of mobile devices. Out of that, let's say MEX server has selected these three to participate. There are dot dot, that means there can be many, but let's say there are these three mobile devices or local devices which are being selected by the MEX server for any particular learning task. And then whatever model it has with it itself, it will push this model update model to these local devices. These local devices are then going to train these local models with the whatever local data sets they are having with them. And once they are done at certain point of time, there'll be a call off, and they'd say that, okay, whatever you have done, let's update it to the central MEX server. And then these locally trained models, their updates are being pushed to this. So a model upload is being done, and these updates are being sent to the MEX server, and then MEX server aggregates all these models, and you have a global model ready. And then if there is next round, this global model is again pushed to this, and then more data is being used to. So this go on, and finally you have a good global model. And you see that the whatever personal data I have within my mobile phone, let's say if I am the first device here, then this data remains here. Only the parameters, update parameters are being sent to the central server. So even if the attacker comes here and gets successful in attacking the server, it will only get the model updates, and privacy is still protected. Okay, now that we have understood this, let's try to understand, are there still issues? Because federated learning, you can say, is giving much more advantage as compared to traditional ML techniques, right? The cost of communication, privacy protection. Then you have better models to be trained, and there'll be there'll be global models available at multiple places if the server where if the aggregation server itself is a decentralized server. So there are a lot of advantages, right? But let's try to understand that what are the issues with even with the federated learning techniques. The first one is lack of incentives for the devices to participate. Now all these devices, they are putting their resources to train the model locally. The question is, how many of us, let's say, are willing to contribute or willing to participate if asked by a MEX server? And if so, there has to be an incentive mechanism which should say that I have participated, then I should get something in return. It could be a monetary benefit, it could be some other services which I get free subscription for, I mean, there can be different models designed, but as of now, there is a problem that there is a lack of incentives, and device would refrain from participating in local training and ultimately participate in federated learning process. Then the next issue is the trust in the locally trained models. How many of us will say that I would use a trained model which has been trained by, let's say, mobile devices? I don't know which are these mobile devices, and they are in different part of the countries. How would I trust them? So trust is problem, because there can be a malicious node and it is pushing the local update. Of course, if there is just one malicious node, it would not make a significant difference to a sizable difference to a global model. But how about two of these nodes are colluding? That means they are secretly uh, how secretly collaborating and trying to attack or trying to come up with you know a corrupted model. They're trying to corrupt that model being trained, right? So independent, there can be independent or there can be colluding malicious devices, and this could be one form of Sybil attack, and this could lead to a model poisoning attack. Okay, then so this is the problem with the locally trained model. How would I trust the locally trained model, right? Then the second problem is, so this problem is that why should I trust these local updates? There has to be some mechanism that should build the trust in the system, that these model updates are correct or they are legitimate as per the service level agreement or whatever norms they have been designed. All right, then uh, if let's say none of them is malicious and they are updating the model, then there can be man in middle attack. These models can be corrupted here, so this can be another security threat. Then another problem is that all these model updates are sent to this centralized MAC server, right? And if this server is centralized, if it is not a decentralized network of MAC servers, and if it's just one server which is aggregating and creating global model, and if that server gets compromised under attack, then the global model can be corrupted. Okay, so that again is a problem, which is single point of failure. Wherever you see a centralized nature popping up in our system, it will lead to a single point of failure, right? And last but not the least, if multiple aggregation servers, then secure and centralized coordinations are issue. Now, as I was saying before, you can have, instead of, let's say, you say that, okay, how about if I'm not using just one MEX server, I'm using like say n number of servers, and they are all decentralized network of MEX servers, and they are independently and they are coordinating with each other. Then if that is also so, of course it will help you overcome with the security attack. Instead of having one MEX server, if you have multiple, then it becomes more difficult for attackers to attack all the servers. So that is good. But how about then the coordination? Because every MEX server will be independently doing its job and then coordinating with others, setting up an agreement that, okay, if everybody is agree to this, we have this as a final global model. So that coordination communication, if that gets compromised, then you again have a security problem over there. Okay, so there can be n number of issues that can come up when you think of using even federated learning, uh, which is better than traditional ML. Okay, so the questions that come up when you think of using blockchain for federated learning: can FL be made more secure with the use of blockchain? And can blockchain make decentralized FL? That's interesting. So FL itself is doing a decentralization in terms of sharing the model and then putting up. Can we do even decentralized federated learning, right? So this is again very interesting. So this paper is the same as this one, right? So one of my collaborator is an author of this paper, so very interesting paper. That's why I'm trying to explain their work. So here you can see that they have a set of MEX servers which are all, you know, which are all connected with each other. They are forming a network of MEX servers, and each MEX servers have multiple local devices. Here you can see there is just one, but you can see either way, you know, every BTS or every base station is connected with two. This is just a pictorial representation. There can be n number of local devices under one base station, and these all MEX servers are connected with each other, forming a network of MEX servers. Right now, the first thing is there can be a local device, and there are two types of you know, entities here: MEX servers and local devices. Local devices again can be can have two role. One is training role, that means which we just now saw. So they can locally train the model and update the training model. Also, they can, if there are much more powerful devices, let's say very powerful as compared to other devices, then they can also participate in the blockchain mining process as well. So you can see there are nodes which are just training nodes. That means they are just updating locally the model, and there can be nodes which are just the mining nodes. They are not training models. They are not doing any training, but they are participating in blockchain mining. Might be they are getting some incentives from mining a new block. Or there can be local device which is powerful, and it can you know, slice its resources for training as well as for mining, right? So, but the MEX servers, of course, it has the job of definitely mining has to be there, because they are much more powerful as compared to the local devices. Okay, so so the first step is that the MEX servers and the local devices, they allocate some resources for creating a blockchain peer-to-peer network. So you can see this training node is not a part of blockchain peer-to-peer network. So you can think of an overlay blockchain peer-to-peer network created with these entities, which is MEX servers and local devices. So some of them are part of that blockchain network, and some of them are not. Okay, so the step one, and then the step two is for any given learning task that is to be done, the MEC will again select some of the nodes, and it will send you know, it these training models, only not just the mining models, but just the training models. After getting the first model, they will start training. So only this part is I'm talking about. They start training the model, and once they are done with the training part, they will update this model to the blockchain network, not to the MEX server, but a logical blockchain network which is running on top of these devices, like logically the part the slice of that. So these model updates are now pushed as a transactions in a blockchain network. So all model updates are cryptographically signed. Who is updating? The digital signature is there, and these updates are getting recorded. They are time stamped, and after a particular instance of time or period of time, what you do, they these all updates as a transactions, they are all put up together, bundled together, and a new block is created. And then starts the next process, which is block mining, right? So all the nodes which are part of blockchain network, they start mining, and there can be different consensus algorithms that can be used. For instance, proof of work or proof of stake or Byzantine fault tolerance or whatever uh, consensus mechanism is suitable here. Since these are all are not very powerful as compared to cloud computing servers or the cloud servers, I think it is important to come up with a consensus mechanism which is not just doing you know, mad cryptographic puzzle solving, which happens in proof of work, but there can be interesting intelligent consensus mechanism that can help to quickly mine a new block. And once this new block is mined, they are available as an update in the blockchain distributed ledger. And once the mining is done, all the blockchain gets updated. Now it is interesting to understand that there are some nodes which are participating in the blockchain mining process, but there are some nodes which are not participating, but still they have a copy. They can be light nodes. They are not participating, but they have a copy of the blockchain ledger. And once the new block is mined, they are not asking for the updates or the model updates from the MEX server. They are just looking in their local copy of the ledger, retrieving the model updates. That means they are reading the transaction from the blockchain, and once they get the local updates, they find out like updates that have they just they just put together all the local updates, and then they itself are getting involved in training the global model. So this is interesting here. So instead of having just the MEX servers doing the global model training or the aggregation, not training, better the global model aggregation, it is the local devices itself which is taking out the local updates from the blockchain, and then they are aggregating and then creating a global model locally, right? So this is interesting. So global models are updated or created, sorry, uh, at these local devices itself in a decentralized fashion, meaning that if this node or if this local device gets compromised, then all the other who are involved in the training process, they are updating the global model. So it is making the system much more decentralized, much more attack immune, and everything whatever they are committing or whatever they are exchanging, even global models or local updates, everything gets registered in a blockchain. And this blockchain, not to forget, is a synchronized ledger. So if anything gets updated here, everybody knows that this node has updated something here, right? So it is very much transparent, it is very much decentralized, and that's how uh, you know and even interestingly, even the aggregation rules, they can be put up in the blockchain. So nobody can take any aggregation rule or maliciously manipulating the aggregation rules and trying to aggregate the local updates to come up with that global model. You have to exactly use the aggregation rules which are available in the blockchain network already, right? So every process, the entire training process gets registered in terms of transactions, and you build trust, security, decentrality, and autonomy in the system. All right. So with this, I think you get the idea of how blockchain can be used for federated learning. And towards the last, we'll quickly look now. The time is getting over, so I'll take like few more minutes, 1 or 2 more minutes, and we'll try to sum up this session. So let's try to look now from the computational intelligence point of view. If you have heuristic algorithms, then what are the issues and how blockchain can help you to have better distributed heuristic algorithms, right? So the heuristic algorithms can be distributed as well. So so you can have, let's say, a master node, and there can be different slave nodes which are all participating in a kind of a distributed heuristic algorithm, right? So normally you would say that there is one node or one server where there is, let's say, any genetic algorithm is being deployed, and it's doing a computation, and it does all that mutation and the crossover and finding out the better chromosomes and what all happens, right? Crossover, mutation, selection, whatever has happening is happening at one place. Instead of that, you can have a hierarchical distributed heuristic algorithms where you have a master which is actually doing some operations of the heuristic algorithm, such as if you talk about genetic algorithm, then the crossover, mutation, and selection, everything is done by the masters. But then after that, the individual updates or the individual what you say I don't know, maybe chromosomes. I'm not from the genetic algorithm point background, but I mean the crux is that whatever they are doing, they can update, and their updates can be sent to these slaves, and these slaves then do the other much more computational tasks such as fitness computation and others if they are there, right? So this is a kind of a scenario where you have a distributed heuristic algorithm where the load can be distributed, and there can be many reasons why you try to come up with an distributed computational intelligent systems, right? However, uh, again, whenever you have a master node, or whenever you have a one place where a lot of things are going on, you end up with the centralized issues, which is single point of failure, attack prone, availability. This master node should be available, and then the third party management, because this master node might be under the control of any one entity uh, which is uh, which is different than the ones who are controlling or who are operating these slaves, right? So here again, if you want to ensure that these all updates, they are legitimate, they are not what you say, they are not corrupted, and they are not illegitimate, they are not malicious, then you can again translate everything in terms of transactions. When you talk about blockchain, in blockchain parlance, you have transactions. So everything can be a transaction recorded, and decentralizedly updated and distributed ledger can be created, and that's how you can implement decentralized and secure distributed genetic algorithms or heuristic algorithms in that sense. So the crux is, if you are done with your models, if you are done with your system in terms of intelligence, it could be AI, ML, federated, heuristic, whatever it is, and if you are planning to come up with a realistic system, and if you want to see a real implementation of your design algorithms, you have to think about how to ensure that whatever you expected comes out. Because if there are if you have to think, the point is, you have to think from the security aspect, privacy aspect, you have to think from the cost aspect, you have to think from you know uh, system getting down. If your server is down, then also is everything intact, is working in the right way that you are expecting. So if you are thinking from those perspectives, I think blockchain is a very useful technology, and it can help you mitigate all those issues. So with that, I think I'm running out of time, so I'll stop here, and thank you everyone for your patience and time. And yeah, I'm up for discussions. We have, I believe, an interaction session as well. So if you have any doubts, questions, or any interactions, to please.
Sorry, sir. Sorry to interrupt you, sir. Can
Yeah.
you take break for 10 minutes as per schedule?
Okay, fine. So let's get back after 10 minutes. Thank you.
Uh-huh.
Dr. Kalla,
Yes, I'm here. Yeah,
uh, can we start interaction section?
sure, please.
I request all the participant, you can put your queries in chat box or raise your hand so that we can unmute your mic.
Yeah, please feel free. I would request all the participants to, if you have like any thought that comes to your mind, uh, if with the use of blockchain, please feel free. Write. You can write in chat box, and I mean, it's okay. I mean, I can try to answer. If not, I can get back to you later. But I mean, don't feel.
Hello.
Yeah.
Yes, sir. I'm Vikas Kumar Jain, sir. I want to ask some question about federated learning, FL.
Yes, please.
Sir, actually, I have discussed about FL, and there is some issue, right? Some different type of attack, and one of attack is poisoning attack. So, malicious node can be changed some parameter when you trend locally. So my question
Yes.
is, what type of algorithm we can use so that we can update globally as well as locally, so that malicious cannot perform some poisoning type of attack.
Right. So that's what I was talking about. So what you can do is you can use blockchain technology here. So if for instance you know the point is it's not just about detecting that there is some malicious node who is trying to poison and locally corrupt the model, and then it could hamper the global model. So the thing is that if everything gets recorded as a transaction in the blockchain, then you can identify that which local devices which are involved. Let's say if there are 100 local devices which you are using to train locally the shared models, and if let's say there is one or two maliciously behaving nodes, then the first point is to identify them and to catch hold of them, that these are the ones who are trying to act maliciously. Either they are maliciously or they are under attack, and they are compromised. So if you are running a blockchain network, or even, so there are two ways you can adapt blockchain technology here. One is that you can run as one of the examples I showed, the architecture. You can have slicing of resources and blockchain running as in certain with certain part of your resources. So the thing is that if you are running blockchain within your network, then you should you should all these updates that they are doing, they should be registered in the blockchain, right? And when they are registered, they are digitally signed. Now when you have some norms, right, that these are the service level agreements, or these are the norms. So at one point of time you can track back everything, and like who were the nodes who were acting malicious in the system. Now what are these rules? And that would depend typically on the use case scenario, and there are different ways to do it, but that's also an ongoing research, how to find out. Let's say it could be a colluding nodes. It could be, let's say if there are 100 nodes, then there could be 20 who are colluding, secretly collaborating, and then trying to do corruption in the global model. So that could be kind of a distributed attack. So the first thing is that you need to have everything recorded in the system, and everybody should understand that these are the ones who are doing it wrong. And then you can employ certain techniques and ways which are specific to a particular scenario, where you try to see like how they can do it. So this is one way. Another way is that you can use blockchain as a service. where you are not employing so this is something like you are not yourself setting up the blockchain network, but then you are using services of a blockchain platform, and every a local device who is updating the model, they are not updating it to an aggregation server, they are updating it to the blockchain, and blockchain again makes it available, and aggregation server has to go to the blockchain service and retrieve the local updates from there. So that's like a two hop solution, but it might be a little expensive, but then still it would be important if you want to mitigate, or if you want to detect such malicious uh, participation.
Okay, sir. Thank you, sir. And one more question, sir.
Yeah.
When we find out malicious node in blockchain, so
Yeah.
there may be two method. I think we can find out synchronous and asynchronous. Actually, I found some method in research paper. So in
Okay.
synchronous, when we found synchronous, so we have to wait for other participant as well. So most of the researcher work on asynchronous algorithm to find out some malicious. So I want to ask, is it best idea in place of synchronous? But it will take us some more time and some more resources.
So is it so that you're talking about synchronous in the sense that majority of should agree that this node is malicious node, and
Yes,
asynchronous means that I independently take a decision?
yes, sir, yes, sir.
Yeah. So if you are independently taking a decision and saying that this node is malicious node, then the question is, I as a third node, I can say you are malicious node, in fact, who is taking a decision and saying that that genuine node is malicious node. So if there are multiple nodes, and if you are not setting up a consensus, then it is difficult to say who is who. Is an attacker saying a genuine node is a malicious node, or it is actually a genuine node saying that this is an attacker? So that's what is the basic concept of the blockchain, is that you have to reach to a consensus before saying, at least the majority of should say that this is right. Then everybody should accept, because you get my point, right?
Yes, sir, yes, sir.
Yeah.
Yeah, okay. Thank you, sir.
Sure.
Yes, anyone else?
So I see one question from Pankaj Pandey saying that examples of blockchain for common people in daily life. So one of the biggest example of blockchain is cryptocurrencies. Of course, they are not legal tenders in India, but still people are investing in. So I'm not talking about from the point of any specific country, but this is one. But the interesting fact is now blockchain has been used in many different other domains, and the practical use has already started. One of the some of them I can, because the list is long, it will take long time much time for me to explain, but just to give you a few examples, the first one is use of blockchain for education, right? I myself have I'm working in this domain. So blockchain has been used by many institutes for issuing the degrees. So normally what happens with the paper based degrees, it is very difficult. You issue it to the student, then a student makes a copy and gives it to the higher education institute where he is trying to pursue higher studies, or for the companies where he's trying to get recruited in, right? So they get a copies of the degrees and transcripts. Then again, that that company or that institute get back to the institute saying that please justify it, and there is a lot of queries, and this is not just happening one time. Every time, even after 10 years down the line, the student has passed out, if student is applying to, let's say, higher education after 10 years of graduation, then again the university will get. So this is very difficult. It is time consuming, it is error prone, and there can be a lot of forgery possible here. So I think it is very interesting for you all participants to know that Niti Aayog has defined some domains where India as a country is planning to, or it's already working towards the use of blockchain. And blockchain for education is one of the use. And nowadays, many institutes, they are issuing degrees which are blockchain, which are verifiable using blockchain platforms, right? So many MOOC courses, they are doing it, and you can find more if you Google, you'll find more details. So this is one area. Another interesting area is the use of a blockchain for land record registry system, right? And again, this is one direction proposed by Niti Aayog. It is not just happening in India, but there are other countries as well. So land record. So I don't remember exactly, but all the disputes, the court cases which are there in India, that report says, if I am not wrong, it says that more than two-thirds of the cases are regarding land disputes. And the state of Andhra Pradesh, if I remember correctly, has collaborated with one of the companies to start up, and they have already, I guess, rolled out a blockchain-based system where they are doing all these land registries uh, on top of a blockchain, so that it is immutable, and like, and there are less disputes possible. So this is another direction. Then there is a blockchain for pharmaceutical supply chain management and healthcare. This is one of the big domain where people are making use of blockchain. Why so? Because healthcare data is very sensitive, and recently in COVID-19 pandemic, we have seen that sharing of medical data is important, but at the same time, it is very much private. I would not like to share my medical history without ensuring that it is protecting my privacy and it is very much secure, and so on and so forth. And I don't know, I myself have this difficulty that I don't have my all medical records securely placed in one digital storage, right? I have I so when you go abroad for higher education and or something else, they would ask you, like, what all injections you have taken, in terms of, like, you have these what vaccinations and all done. So from the day of your birth till today, entire vaccination history and blah blah and so on and so forth. So it is very difficult to put everything in one place. One, because these medical data are very sensitive, they should not be shared. And second, there is no one consortium of medical organizations and institutes and hospitals and medicinal practitioners who can all be a part of this consortium system, and they can put everything there. So this is one big area where a lot of use of blockchain is going on. Then blockchain is being used for decentralized and distributed energy management. There are renewable energy resources, they are coming up. Let's say I have a solar panel installed at top of my house, and let's say I'm producing some amount of electricity with that solar panel system. However, I am not able to use, let's say, 100% of what it is generating. I might be have some leftover or over generation. So how I can pool this over generation to someone who is willing to have this, and can there be a decentralized system? If there is a centralized system, government based system, then again there is a lot of problem. Can it happen peer to peer basis on very short very short time duration, saying that I have a surplus amount of energy for next 1 hour? Is somebody there willing to take up? And this all happens without disclosing the identity, and in a trusted fashion, in a environment which is a trustless environment. But it ensures, because if you have a smart contract which complies you to follow this, then if you have given the extra energy to someone, according to the smart contract, it will automatically be executed after 1 hour, and you will get the payment. So payment settlements and everything is very easy. So as I said, the list is very long and I can go on and on, but I think I should stop here. Any more queries, please?
Rajesh sir, I think there is no more query from the participants, so you can conclude.
Okay. I would like to extend my gratitude to Dr. Anshuman Kalla for sparing his valuable time today. Sir, your presentation was really very insightful and provided with a lot of valuable information regarding blockchain for AI and computational intelligence. I truly feel that this knowledge will help us a lot in the years to come. I thank all the participants for joining this session. We will meeting tomorrow as per schedule. On the behalf of program coordinator, I announce that today's session is over now. Thank you so much. That's all for today.
Okay, thanks a lot, Dr. Kalla, for providing such a effective presentation, and no doubt participant has been benefited. Thanks a lot.
Thank you, Dr. Sushant Upadhyay ji, for inviting me. It was pleasure. Thank you.
Welcome. Thank you.